So, problem number 7. We want to compute the range and standard deviation for each of the values given. So, you can do it with Excel, you can do it with the calculator. I'm going to do it with the calculator, follow the same steps we've done before. So I'm going to input all the data. 3200, 2980. You can type it either on the keyboard or on the calculator. It should input either way. Alright, so again, the most common error is data entry, so double check that everything is correct. So I've got 3930, 4080, 3400, 3200, 2980, 3840, 4080, 4010. Alright, you do stat. You can do over to calculate, one variable statistics, compute, and then it gives you a lot of information. So we want the sample standard deviation, so that's given to us here. The SX. Don't know how many decimal places yet. Normally you go one more than the place value you have, so we're going to say 433.4. That's normal. Just go one more place value than what you have in your original data. So this is our sample standard deviation. The range is going to be the difference from the largest and the smallest value. So if you scroll down, you have more information. It tells you what the smallest value is, the minimum. Tells you what the maximum value is. So 4080 minus 2980. And that gives us a range of 1100. Okay. So these are the two measurements we're looking for here. 1100. And then round to one decimal place, so that's the 433.4. Alright, so in number 8 we have two histograms. We want to know which one has the higher standard deviation. So higher means there's more spread, they're more spread out. If you look at the data values and their endpoints, so it looks like this graph goes a little bit longer than this graph, but if you look at the numbers, this one is from 40 to 60. So if you were to subtract those, 60 take away 40, just a measure of the range tells you that the spread from the lowest to the highest is 20. If you look at the other graph, which looks like it's much closer, you have a high value of 70, you're going to take away 30, and you get a spread of 40. So there's a bigger range here. So this one would have the higher standard deviation because those are more spread out, even though the picture is kind of misleading. If you look at it, it looks like this one is more spread out, even though it's closer together. It looks like this one is closer together, but it's more spread out based on the numbering, how they label the x-axis. So B depicts a higher standard deviation since it's more bell-shaped. Histogram A is the higher standard deviation because the bars are higher. C says histogram B depicts a higher standard deviation because the distribution has more dispersion. That's going to be the correct explanation here. And then D says A is higher because the distribution has more dispersion. So it looks like B has more dispersion.